Now we can do what you were suggesting earlier and plug in more detail, the variables for each term. So let's do that now. What specific variables do we plug in for gravitational potential energy initial? What's our general formula for that?
mgh initial.
Good. And there's nothing else to plug in on the left-hand side. Everything else was 0. So now what do we plug in on the right-hand side?
1/2 mv final squared plus 1/2 I omega f squared.
1/2 I omega final squared. Very good. Okay, now as a matter of problem-solving skills, notice that it was really much better that we crossed out the 0 terms before we did this step. Because if we hadn't crossed out the 0 terms at the beginning, this step would have been much more complicated, right? There would have been 6 different terms. It would have been a great big mess like we did originally with 6 complicated terms. So as soon as you see that one of the energies is 0, you might as well cross it out. So there's no need to plug in for it more specifically. Do you see what I mean by that?
I do.
Okay, good. All right, now what? Or actually, one thing that would be excellent to do now, I hope maybe you're getting in the habit of doing this, now would be an excellent time to write down what the question was. So remind me again, what's the question?
What will be the cylinder speed at the bottom? So that is going to tell us our translational kinetic final, so that's going to be what we're looking for.
So what symbol should I write down next to my question mark? What's the specific symbol the question's asking us for?
Velocity.
Initial or final?
Final.
Very good. Okay. So I think we've talked about this a lot in the past. It's a really good habit to get to in physics as soon as possible to use a question mark to label the question, and when possible you want to write down the symbol that you're going to use for the concept that the question is asking about. So here the question is asking us for the final speed. Remember that earlier, for a second, you thought that maybe the speed would be 0 at the bottom. But if we had written down the question, that would help us to notice that it wouldn't make sense for the speed to be 0 because then there wouldn't really be any question there. Okay, so it's good to write down that question. All right, so let's go back to our equation. What now? What should we do now?
We should plug in.
Right, so let's go ahead and do that. What can we plug in? We may not be able to plug in for everything. What can we plug in?
We can plug in for mass. We can plug in for gravity.
What are you going to plug in for mass?
5.
5 what's?
Oh, okay, no.
Yeah, so it turns out I didn't give you the mass, right? It turns out that we weren't given the mass here. It's always good to focus on the units. That 5 is in meters, so we know that's not a mass. All right, so it would be nice if we could plug in the mass, but we'll have to hold off on that. So what information do we have that we can plug in?
Well, we have the 20 degrees. And we have 5 meters for a radius. Let's see. We have a, oh, we can figure out the velocity. No, let me see here. 5 meters. I don't know.
Okay.
I don't know what we can plug in.
Huh. Well, let's see here. How about G?
Well, yeah, we can plug in G.
Okay, so let's do that. Every little bit helps. What can we plug in for G?
9.8.
Okay. All right, how about H initial? How can we figure out that? What does H initial represent in our picture?
The height.
Okay.
Okay.
So is that the hypotenuse, the vertical, or the horizontal?
It's going to be the vertical. It's going to be our y.
Good. So we emphasized before that height refers to the vertical distance. Now, I didn't tell you that, but is there any way we can figure that out?
Yeah, by using trigonometry.
Okay, so go ahead and take a piece of paper and work that out. And talk me through your steps so I can make sure that we're on the right track.
Okay, so, let's see. Opposite equals sine of 20 times 10. And so we have our h equals 3.4.
Good. Oh, give me a second. I forgot to have my calculator at hand. Give me 1 second to get that.
Okay.
Yeah, what did you get again?
3.4
I agree.
meters.
Good. Okay, so what are we going to plug in for H initial?
Oh. Okay, hold on 1 second.
No, you're doing good. It's just a straightforward question. What's our initial height?
Oh no, I just had to erase something
Okay.
real quick because I put it in the way of me solving my equation. So so for H initial, I'll put 3.4.
Okay, good. Okay. All right, that's good. Looks like you remembered that trick. That's good. So let me erase that. 1 sec. Okay. All right. Let's see. How about, we already decided we can't plug in for M on the right-hand side. How about V final? Well, we definitely can't plug in for that because that's the question. How about I? What can you tell me about how we could figure out I in this problem?
The only thing really I can tell you about I is that I know that it's the, you know, it has the same influence on the equations that mass does. Does that mean that we would be able to cancel out with the masses?
That's actually a good instinct there. It's maybe a little bit more complicated than you're thinking, but you're on the right track. Let's work that out in more specifically. So to be specific, how would we actually calculate the I for this object? What do we need to calculate the I?
Well, I know I is the sum of masses times the r perpendicular squared.
Let's see. Okay, let's actually go back and review that a little bit. So,
but that's only for a point mass only.
That's what I was going to remind you of.
Okay, so we would have to say that the only other I formula that I know is the using the net torque. So I mean, other than that,
that's right. Now that we actually did talk briefly, though, I think about the other way to find I. What do you do when you have an extended object? How do you find the I for an extended object? Do you remember that there's that table in the book?
Oh, that's right.
Okay. Yeah, we actually didn't talk about that very much, so I should have just reminded you of that. So let's go. You have your textbook with you?
Yes.
All right. So see if you can find that table. What page is that on?
I think it's 273.
Okay. That's a page you might want to mark, or maybe you got it marked. Tell me when you got that. Here's the table in the textbook that the student is using. You may not be able to see this clearly on the video, but anyway, hopefully you can find the similar table in your own textbook. It should be in the chapter on rotation, and it should show you how to find the moments of inertia for various objects with different shapes. The way to use the table is to make sure that you're picking out the correct shape and also the correct axis of rotation. All right, now you can see that there's a whole bunch of different examples there. So let's make sure you're picking out the right one. Which of those formulas seems relevant in this case?
E.
Solid
cylinder.
Yeah, if we go back to the problem said that we've got a solid cylinder. So we look for the formula for the solid cylinder. What's the axis of rotation for our cylinder? What point is our cylinder rotating around?
The center point?
Yeah, it's common sense here that we're rotating around the center. Well, you can look at formula E and you can see that's the formula for a solid cylinder where the axis is through the center. Okay, so that formula is 1/2 m r squared. All right, now what are we going to plug in for m? Well, we still don't know what the mass is, but one thing we can do is, in that formula they use a capital M for the mass. But in the equation so far I've been using lowercase m, and so I'll change that into a lowercase m, but that's all I can really do for that. Okay. All right, is there anything we can plug into this formula?
Yes, finally our 5 meter radius.
Yes, well put, that's right. So now we can put in that radius. That's where the radius goes in. So now what?
Um, do we just solve for m, or?
Well, we can't really solve for anything here because we've got two unknowns. The natural thing to do now is to do some calculations and simplify this. Anytime you have a bunch of numbers, it's a good idea to do some calculations and simplify. Do you see what I mean? We get 1/2 and 5 squared. What calculations can we do to simplify this?
Oh, that's what I meant.
Ah, then you were right. Okay.
Okay. So it would be 50.
How'd you get that?
You'd say 25 equals 1/2 m. You'd use
Okay,
square
I think
root 5.
you might have gotten a little confused in your equation. So